With a binomial theorem, what we're trying to do is find out how to expand binomials that have very high indices versus going through the long process of expanding them and then multiplying. So this is the equation for it. It looks very daunting, but it's not. So this is a summation sign. And it means as you progress, you add them together, the terms or whatever the operations are. And this is a regression where they get smaller as you go. So we're going to go and look at the combination now. This is the equation. And this is n factorial. Let's say n is 4, so you do 4 times 3 times 2 times 1. And this is r factorial. Let's say r is 8, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And there's a lot of canceling involved, so it makes the math a little easier. Let's go through an example problem. And we're going to expand this. This wouldn't be too time consumptive if we went ahead and did it the long way, but just for the sake of practicing, I'm going to keep the index relatively low. And here's the first term. And as I go through, I increase this value. I decrease this value by 1, and then increase this value by 1. The next term, this index loses 1, and this index gains 1, and we go through the regression. And here's our setup. So notice that the k increases each time, right? And same with the k factorial. So it increases each time as you go through the summation. And here's our final one I had to squeeze on the bottom because it's getting kind of long. And now we just have to work it out and solve it. I'm actually going to start with the last term this time, which I just wrote y to the 8th right here. And the reason for that is if we go look at the last term, this is 0 factorial, which is equal to 1, and this is 4 factorial, so we can cancel these out. And 3x to the 0 power is just 1. So we can disregard that, and we could use the power rule. Y squared raised to the 4th power is y to the 8th. And that's our final term. And now we can talk about expanding these factorials. And we've got 4 factorial, and we can cancel that out with 4 factorial. 0 factorial is just 1. So our first term is going to be 81x to the 4th. And this I expanded. 4 factorial times 3 factorial is, 4 times 3 factorial is the same as 3 factorial. And I just expanded it just to make it a little easier to see that we're just going to cancel this 3 factorial. So we're just left with a 4. So we can cancel these. 1 factorial we can disregard, and we're going to multiply those out. And I expanded it here just the same for the same reason. So 2 factorial. And we can get rid of one of these 2 factorials. Doesn't matter which one it is. This one. Again, it's 4 times 3 factorial, so we just cancel those out. And now we just need to do a little bit of math, and we're going to have the final answer. And this should be the final answer. So that's the expanded form of what we found here. And that's going to be if we were to have gone 3x minus y squared. And we did this 4 times. And I'm not sure which way is quicker, to be honest, but when these have really high indices, it's obviously quicker to use the binomial theorem. And I'm just going to finish this out. Minus y squared. I would prefer to use the binomial theorem. Actually, once I'm looking at all this, imagine going through and multiplying that. That would take up too much time. So the binomial binomial theorem is definitely the way to go.